Hey guys, very nice to meet you. Welcome to DevOps Europe. I'm super excited to be able to talk to you today. My name is Laurent Gilles. I'm one of the founder of a company called Cast AI, and I run all the product for the company. Super excited to talk to you about some approach of using automation to handle your Kubernetes cost, especially how do you optimize cost for Kubernetes applications. So I'm going to show you a few slides of how we do this and what we think about it. Here we go, and then I'll show you a demo of how effectively you can use automation to make the magic happens. So here's the idea. First, we start from a problem. And the problem, in my opinion, is a very big problem. We see this in absolutely almost all our customers and friends in the industry. The first one is from Datadog. Half of Kubernetes applications use less than 30% of CPU resource. I mean, think about it. Half statistically from Datadog, and I think this was in 2020, half of the application, half of Kubernetes applications or containerized applications on any cloud use less than a third of the resource. So if you think of this as the old world was on-prem, then it's by design. It takes a few months to add a server when you are in your own data center. So you want to over-provision because you have to plan for these 3 months in front of you. But if you're thinking of the cloud, then here it just said that you're paying 2/3 of your bill to Amazon or to Google or to Azure, just so that Mr. Bezos can buy a new yacht, because that does nothing to you. You are paying for resources that you will never use, that your application will absolutely never use, and you're paying 3 times more for half of the application, according to Datadog. There's another stat, it's more academic, that made a study where in their sample, 90% of the applications use have 5 times more resources than they actually need. So between these two things, you can see the vast issue we have. And then, yes, but if your AWS Kubernetes bill also went way over your budget this month, it's not really your fault. And we also see this a lot with our customer. It's not your fault because it's by design. Like, the cloud providers are really not helping you there. The bills are long, they are complicated, they are very hard to understand. Not only this, if you think of AWS alone, they have like 150 type of EC2 instance available. So which one do you choose for your apps? And this is an example of a bill, but believe me, we in a previous company, we were spending about a few $1,000,000 a year on AWS. Our bill was 80K. But what do you do about it? So every month we would see this bill, we would try to think, what do we do about this? Doesn't matter. Whatever you do about it, the next month would be another 10% increase. It's extremely hard to do this. This is why we say it's by design. Cloud providers love this fact that you over provision. They love the fact that their bill are hard to understand. It is hard for a cloud provider to say, hey, I'm going to give you a lot of tools so you don't need to spend that much money. This is the by design idea. We're not blaming them. It's just they are running their business a very nice way, and it's great for them. It's just not great for us and us users, developers, and customers that are suffering from all this. So cloud providers give you a few tools to try to reduce your bill. So the on-demand is the most expensive type. This is I need 5 machines right now. Then you're gonna pay full list price for this. You pay 100% of the cost. You can use reserve instance and saving plans. Then your discount would probably be between 20 and 45%. Or you can use spot instance. I'm going to go into each of these, reserve and spot, and show you some ideas of what we do about it and how you effectively can use this to your benefit. So the first, the reserve instance or the saving plan, fairly similar. Reserve instance means that you are committing to AWS that you are buying a certain type of machine, and you have to have them for 1 year to 3 years. So even if you don't use them, they are in your account, you're paying for them every month, but you're paying a 40, 45, 20% discount on this machine. That's what reserve instance is. Savings plan is kind of similar idea. All the other cloud providers have something that looks like this. The savings plan says, hey, I'm going to commit that I will spend 100,000 euro per month to you, even if I don't. So my bill will at least be 100,000, and by committing that you will spend that amount of money, AWS will also give you a small discount. Oh, sometimes it's quite significant. We've seen example where you have a discount of 22, 23% on savings plan for 1 year plan. But I really don't like it. In my opinion, as we are running our business, as we are running our teams, and we're doing our budget, why do you have to commit for 1 year to 3 years when you don't even know how much of these resources you should really use? And by the way, maybe next month will not be the same as today. Right? That's why I call this a deal. Reserve instance or ABIL, savings plans or ABIL, because it's a form of the cloud provider to lock you in. Either with reserve instance, they lock you into a family of machine. You cannot get out of it. You can resell them, maybe, but you commit to use them even if you don't need them. And the savings plan is the same, except it's not a machine. It's more a dollar commitment. And it kind of eliminates all the flexibility. And it also eliminates the will to right size better. Just because you say, well, I will spend that money anyway, therefore I don't need to optimize. But that's the reason why I don't like this idea of paying in advance or committing to pay something or committing to use a family of machine, which is the reserve instance. The spot instance, in my opinion, is a much more effective and elegant solution. Spot instance is the fact that you can buy idle capacity from Google, Amazon, or Azure. I think other hyperscalers are going into it. We heard from some of our friends. So that becomes a popular way of doing it. The problem with this is, in the case of AWS, but the others are the same, they can pull the plug within a 2-minute warning. So you use a very highly discounted VM. Highly discounted means between, you know, usually 40 to 80% discount. But then if Amazon need it back, they will tell you in 10 minutes, hey, I'm sorry, but the spot instance you use, you only can enjoy it for another 2 minutes. I need the machine back. So you have to be able to manage interrupt. The good news is Kubernetes is it's almost designed for it. So that's great. That's why I like spot instance. I'll show you some example of it where you're able to commit spot instance, manage interrupt, find them, discover them, and add them into your Kubernetes cluster. That will come in a few minutes. By the way, if you guys have questions, don't mind, please put them in the Q&A, and I will look at the end. I can't see them right now, but I will see them at the end. I will answer all your questions. So don't hesitate to ask questions in the Q&A. All right, so first, for instance, you have to manage interrupt. The good news is Kubernetes is almost designed for this in mind, especially when you have stateless pods. Stateless means you have no storage. Therefore, if there is an interrupt, no problem. You just find a new spot instance, or you find a new VM. You install your pods, it's automatic, and usually you have almost no interrupt in your application. But it's not as easy as what I said. So here's an example. It's actually a study that we did a few days ago. I think it was US East Virginia. It's also an AWS. And we look at what is the minimum and the maximum discount of spot instance within the availability zone of US East Virginia on AWS. And we see that for the same instance, let's say this M580.4x which is 64 gig of RAM, some availability zone have a 66% discount, but others have only 18. Now, 18 is better than nothing, but you can see the price varies not just by the family, but also by the location you are, and not just by the location, but also by the availability zone that you have. And that gave us a little bit of pause in how we advise customer to use spot instance. We are saying now that when you look at the spot instance, don't really look at the family you need, but look more as what is your requirement or the minimum requirement of CPU and memory. Don't mind if one instance have bigger IOPS, maybe another instance have a disk and others don't. If what you're looking for is a pure amount of CPU and memory, then it's okay to go across families. Let the first two, for example, provide you the same CPU and the same memory quantity. They are not the same family. One is M580 and the other one is H1, but the discount is very different. So if you happen to be unlucky and you're in the availability zone where the M580 is only 18% discount, maybe the same availability zone for H1.4X will have the 70% one. So when you look at spot instance, don't use, try to not use the pool, the standard pool that Amazon give you. Don't use the pool because the pool will decide the family, and maybe that family has low inventory, or you are unlucky and you have a lower discount because of your availability zone. Just look at, this is my requirement. This is what I need. I need 16, I need at least 16 core and at least 64 gig of RAM, or maybe I need only 32 gig of RAM, but it happened that the H1 large fit my requirement, even though it's not the ideal family, and maybe I would have preferred C5A. It doesn't matter. You'll get the discount anyway. So you can use AWS Spot Instance for what it was not really designed for, just because you decide your requirement and you are open-minded in whatever is available within my requirement, I'll take because of the discount I'll get. So this is what we see now and what we advise customer to do. It's better if you can do this automatically. And that's why an AI engine or machine learning engine comes very handy. But everything I said on selection of, for instance, think of this as now it becomes the policy of your application. The policy is very simple. Every time I have containers, I have no place to run. That's called the unscheduled pod in the Kubernetes language. So every time I have pod that have no place to run, you decide, or you have an engine that says, I need that amount of CPU and that amount of memory. And then you have the engine scan all the availability of AWS in the region or the availability zone you operate. And don't mind if you may not select the family that you thought would be appropriate, you let the engine sort and try to fit into all the availability that AWS will give you, fit what you need so that you maximize the distance. So don't use spot instance tool. Just use a little bit smarter but not very complicated automation that will try to fit just based on your requirement of CPU and memory, I will try to fit the selection of the many instances that all together is fitting your requirement. That's we advise, and that's why automation is a great tool for Kubernetes. Now, it is still a very hard problem to solve, and these are the three questions that developers or DevOps team always have to answer. The first one is, okay, so this is my application here. I need to decide how many machines I need. I need to decide what is their size. Then I need to decide how many duplicates of pods or containers I need. I need to, do I need one version? Do I need 5? Do I need 1,000 of them? Then I also need to decide for each of these pods, what should be the ideal size of them. But you can think of, this is why this is so hard to do manually. This is why now we can understand there is so much over provisioning, almost by 3x factor, for that according to Datadog. Because this answer to these three questions is almost impossible. If you fix the first question, you say, okay, I will deploy 20 machines to live with all of that family, then the answer to the first question will impact the second, and the third. So any of these questions that you try to answer will have a direct influence on the others. This is why doing this by hand is almost an impossible task. This is why automation is a great idea. Why do you need to answer how many machines you need? Why do you need to answer what kind of machine you need? Why do you need to answer how many pods do I need to duplicate in the beginning? Why do you need to know what the size should be? Wouldn't it be great that you have some form of automation that will give this, or at least we'll try a few of these and can read them until you find the most optimal way to manage your application. This is what we tell customers now and friends and colleagues. The three autoscaling for Kubernetes are the one I just mentioned. The first one is called horizontal pod autoscaler. The answer is, how many duplicates can I do of my microservice? The second question is, what should be their size with vertical pod autoscaler, which is a very, very nice project that is telling you, well, that is recommending, sorry, what should be the ideal size of my pods. And the third one is, once you have a great horizontal pod autoscaler and a great vertical pod autoscaler, then you can have an automation for how many VMs should all this fit in. The third point is really the consequence of question one and answer one and answer two, in our opinion. So I'll go to each of them and I'll show you some of the ideas and recommendations that we have. The first one is the horizontal autoscaling, which you can say in English as adding more of the same. So the thing with Kubernetes is you can duplicate pods very easily. The difficulty is, when should I duplicate them? The HPA, the horizontal autoscaling, is the answer to that question. I am a big fan of KEDA. Because KEDA is a version of HPA where you can decide the autoscaling based on application metrics. So typically, the old world would say, well, every time my CPU goes to the roof, it's a great indication that I need to duplicate some of these containers because they are too busy. Right? CPU goes to the roof. And as soon as duplicate them, they may trigger adding a new VM, or they will be installed in the available VM that I have. A VM is the same as node in the Kubernetes language. The better way we think to see this is use something like KEDA, where you are able to trigger the duplicate of a container based on application metrics, any application metric, including even a business metric. The example I'm showing here is the use of KEDA that would trigger a duplicate based on how many HTTP requests I got in the last 2 minutes. It's much more sophisticated than my CPU goes to the roof, I need to duplicate the container. Here you say, I'll duplicate the container if my threshold is higher than a certain amount of HTTP requests over a period of time. But think of this also, you can use another kind of metrics that says, how many customers do I have logged in right now? That's another very, very smart way of using horizontal pod autoscaler. So guys, if you don't know KEDA, look at it. I'm a big fan of it because it allows you to do this flexibility with HPA. Vertical autoscaler is the answer of, should I make the pod smaller or bigger? It's a very nice recommendation engine. It's also one of the projects I really like in the Kubernetes community. Use VPA at first with update mode off so that it doesn't trigger automatic resizing of your pods. But the good thing of the recommendation is at least it gives you some better view of how many CPU and memory quantities a pod should use, a container should use, based on a recommendation engine that is looking at the real usage of this pod. Really like this. It's a great tool to use in conjunction with HPA when some workload might experience temporary high utilization. So let's say that they're not too utilized normally, so we can resize the pod to the bare minimum. We don't need a lot of compute, but from time to time, they may have a sudden increase of workload. That's when you should use VPA. You will increase the pod size only at that time where the engine thinks that it needs to. Otherwise, you will go back to the bare minimum. Remember, every time it changes, the pod is going down and will be reinstalled. So if this is an example, sorry, of what VPA looked like, and you can see this is just a screenshot I took this morning, where you get a few recommendations, lower bound target, uncapped target, and upper bound. And this example is just something I did real quick. My initial number was I need 50 millicore and 10 meg, and I was completely wrong because the target, the system says no, you should use 587 millicore and 250 meg. So a great example of why VPA is useful. I don't need to think too much about it. I let the system tell me. The trade-off between HPA and VPA is quite easy to understand. The idea is if your size of container varies too much, so if VPA is telling you so many times that you need to change the size, then it's probably an indication that you should not change the size of the pod, but you should duplicate it instead. So that's how you do the trade-off between VPA and HPA. Every time the recommendation engine says that it should change too much, too fast, it tells the developer that for this particular pod, it's probably a lot more useful to duplicate it with the same size instead of using VPA. Because every time you use VPA, the pod will go down and then will go back up with the new size. And so these are the trade-off between these. So it's not very complicated. You just need to know and understand the difference between them. Finally, the third autoscaling element is what I call the cluster autoscaler. That's the answer of how many machines do I need, but also what kind of machine do I need? And also, maybe I need more than one family. Example of the Spot instance. If I want to use Spot and my ideal configuration may be a C5A, well, there will be cases where maybe the M5 or the M5A will be cheaper because it will be more available within the availability zone I have. Even though I don't need the extra memory of an M5, it's okay because my discount will be higher by using M5 compared to that by using the C5A. That would be the ideal Spot usage. Right? So Cluster Scalar is great because it should answer all these questions. You have to be smart about it. You have to make it in a way that you don't want to use node ports. You don't want to use the same node every time you need to trigger one. You have to be smart in the selection of the VM as you need them, with also some automation there. This is an example of, it's actually a real example of a customer. I'm showing to you the before and after. So before means before any optimization was applied. This cluster is a very old cluster, it's a few years old. And as you can tell, the older it is, the more different machines it used, because many of these, or actually all of them, were kind of manually designed or manually selected, right? So you can see there's a few M4, C4, C5, and R4. And there's for odd reason only one R4 and a bunch of others. So it's a very large bill. This client is paying a lot of money to Amazon. So they are they are right now paying 180K. This is what the AI engine recommends. So we looked at HPA, we looked at VPA to resize the pod. We also looked at what is the ideal type of machine we should use for this cluster. And that's what the engine said. It says, well, if you can use C5A and you have enough of them, deploy 19 of them. And the engine also said there are a bunch of pods that can be using Spot instance. Use them every time you can. The ideal configuration of a Spot instance is a C5A. You need almost 80 of them in that region. But don't worry, dear application. If I can't find C5A, but I can only find M5, that's also fine. They fit within my requirement. Therefore, it's okay to have many kind of Spot instance because that's where the cost optimization for this, in particular for this example, would come from. And if you do all this nicely, this client or this application will see a dramatic lower bill from Amazon. This is a real number. They are using 3,000 pods. Almost 2,000 are Spot friendly, meaning they are stateless, they have duplicate more than one. They can easily go into a Spot instance. Therefore, the engine did a smart selection and says, let's have much more Spot instance than you had before. And it's okay if the C5A is not available. I'll just use others. So think about this as this. This application spends $1.2 million a year. That is absolutely useless. That's the annual savings. But think of this as this app is giving to Mr. Jeff Bezos $1.2 million every year for free. It's a gift because it's not used by this application. It is not necessary. But if you think of this way, this app, it's worth thinking of optimizing it because the amount of savings is such that even if you achieve only half of this, it's a great return of investment for you to spend a few hours to handle it. I'm going to show you a demo of this so you can see this in real time. It takes a few minutes, so we may not finish the demo, but at least you'll see the concept of it. So the application I will demo is a batch application. It's a typical nice microservice. It's an app, it's a cybersecurity app. So you are sending files to input. They are trying to look for code in the file. If there is, and there was the output is yes, there was a fraud, or no, there was no fraud in this file. The file is a user activity on the payment platform. So very simple, typical Kubernetes, all microservice, all stateless. The request has encapsulated the data to come in and is sending the data out to the next microservice of this app. So very super simple. What I'll do is I'm gonna send 150 files to process to this app. This app has one worker node, one master node. It's on AWS. The worker node is a T3A, obviously quite small for 150 files. But let's see what happens. So I'm going to start here now. So here I am running a small batch process that says it's going to run 150 files. It's going to send 150 files to this app. I'm using Amazon SQS to manage the queue. Let's see if some files are coming. Yeah, the first 4 files are there. So it's as the time goes, more and more, I'm sure more and more, yeah, no, right now I'm at 12, and it will go up to 150 at some point. It's a random amount of file coming in, so it's not all 150 in 1 second. It's a kind of a random random queue. I wanted to make it random so you guys can see it in real time. My pods. This is this is a very nice package that says these are my 2 VMs, my 2 nodes. This one is the master node. This one is a worker node. You can see all these files are creating new pods. Some of these pods went into the worker node that was available, but obviously you have a bunch of unscheduled ones. That is the purpose of it. They are unscheduled, therefore. So what happened here? My HPA said I use Keda, and Keda is saying every time there is a file, create a new pod. That's how my horizontal pod autoscaling is working. Then I have a cluster autoscaling that says every time I have unscheduled pods, dear engine, please make a smart selection of what is the best VM possible to handle them. Of course, pods are coming over time, so the answer right now is not the same as probably the answer in 2 minutes. But that's what the great machine learning engine is for. It's going to try to smartly analyze the amount of quantity of work and make a selection of what VM I should use. If you look at the VM, let me refresh that screen. We should start to see, yeah, you see there is already one. It's a C5A, 2x large, that has been created. It's pending, so it takes about 2 minutes for Amazon to have it working. It's going to be a worker node. And this is designed to handle some of these yellow unscheduled pods. So in about a minute, oh, well, you see it's happening now. So this is the first VM. So if I go into my console, it probably is going to say ready at some point. Let's go and see. Oh, it's still pending. It means we're still installing some pod into this machine. Yeah, you can see the first one you see here. These are the pods that are used by our machine learning engine. And this machine is now available. It's ready. It took a bunch of these unscheduled pods. And as soon as they are working, they would probably become gray. So you see how it works, right? Smart selection of resource. Obviously, this is not enough. You still have a bunch of other unscheduled pods that are appearing. They are continuing to appear. And that will probably continue to trigger an event that says, hey, dear engine, it was great that you found the C5A, which is for instance, so it's nice, it's discounted. it's not enough. You please add more. Oh, and you see now, that's exactly what the engine did. And a thing you notice is the engine didn't add all C5 to X. Like there's a 4X lot that the engine decided, probably because if I would guess, there are so many of these unscheduled pods. They continue to arrive with quite an acceleration number that I'm sure the engine says, I need a much bigger machine than the 2X. If you go to Grafana and see CPU utilization, yeah, you can tell here. Let me make this bigger. You can tell here what I was saying. So in the dormant state, I was supplying 6 core, that includes the master node. I was supplying 6 core for requested 2. Then I have this sudden increase of traffic. These are all my files that I'm sending. I started to request 20 core, but I only had 6. The first decision was by the engine, hey, I got you. I will create a C5A2X, which is, I think it's an 8-core machine. So that's why the green went to 14 from 6. It's not enough. It's not enough just because it continues to increase here, and then there's an even bigger increase here. And that's why the engine added more. And you can see that now we're adding more. The only thing you really need to manage when you do this is this 2-minute interval that it takes for Amazon to add a new VM into your account. And that's a 2-minute interval. So that really is the only question the engine has to think of is, what machine do you need now? And think a little bit smarter in what machine may you need in 2 minutes, because it will take me 2 minutes to wait. That's probably exactly what's happening. And I guess that I bet that's the reason why the C5A4X was created, probably because the engine felt, and it's still pending, so it will come soon, but probably because the engine felt we need a much bigger machine to handle. If I go back to my pods, yeah, you see this one was created. Actually, this new machine was created, but there is no more unscheduled, so let's see what happened. This machine may disappear very quickly just because it has nothing to do. But let's see, it's kind of unpredictable. Maybe I haven't sent all my files. Maybe there are still some files that will be sent. Maybe there will be some unscheduled files. That's the nice thing of using an automation here. You don't really need to worry about it. You just let this engine do it for you. If you go back to the CPU utilization, yeah, that's what I was saying. Continue to increase until around 7:51 a.m. local time. These are the 3 VM that were added successively. 8 core. I think this probably is another 8 core, and this one is a 16 core. I am currently supplying enough CPU compared to what I requested. I'm requesting 31.3. I'm supplying 38. That means the engine is happy. It did the right decision. These pods, it actually did a little bit of even over provisioning, but it was probably the right decision in the 2 minutes prior to having this machine up and running. Because this machine is empty, it will be deleted, I'm quite sure. That's the typical of what this will say. And then as soon as this as soon as my file will stop being sent, oh, you see, right now I have a decrease of them, then I'm quite sure that some of these VM will start to disappear from my account. So I go back here, they're all in the ready state. I refresh this. At some point, some will be deleting or deleted, just because the burst event or the right sizing event will have completed. There will be no more need to keep them up and running. Therefore, they will disappear. So, oh yeah, you can see here now, all my request was done. So right now I only need 17. I'm still supplying 38, and that should trigger some of these to say, hey, you probably need to start to delete some of them. It take about a few seconds, I'm sure, for the engine to make that decision. So this was just an example of, with automation, with the right HPA, I'm not using DPA for that demo, but with the right HPA, in this case, create a duplicate of a pod every time there is a new file to process, then having a right cluster autoscaling that says, hey, if I have a bunch of unscheduled pods that I need, and I need to create a new VM, what is the best type of VM I should add? Don't make the assumption that you should always add the same family. In fact, oh, sorry. In this case, I actually added the same family. I got lucky in my availability zone. This, I think it's US East on this one. but the engine still decided to use a 2x and a 4x in combination because that was the most appropriate. You can tell these nodes are being deleted right now. And so if I go back here, you probably see, yeah, you see the first one here has been taken out of my account, and there will be a bunch of others that will be taken out as well. And at some point, at the end of this, once all of this is deleted, yeah, the one has disappeared already. This one is still being used by the remaining pods. As soon as this is done, I will not need any of this, and therefore my application will go back to my dormant state, which was the one I started in the beginning with one worker node on AWS. I don't need my Spot instance anymore. Yeah, you see it's training now. So if I go back here, I'll have my green line going down to where it was just before I started my right sizing. So an example of HPA with SCADA plus an example of being smart in selecting the right type of instance. Yeah, and I'm back to my dormant state. My cluster autoscaler told me, hey, this node is empty, you don't need it anymore, let's delete once the event is complete. So that's a demo of how do you use this combination HPA plus cluster autoscaling with a being smart in the sense that you let the engine decide for you what is the size and the type of instance you need to add. And in that particular case, add Spot instance if you can, which is great in this case because it's all microservice and it's all stateless. Ideal case to use a Spot. So that was what I wanted to show you. Yes, there is hope. Use HPA, use VPA, use cluster autoscaling. Don't assume that you should always use the same family of machines. Use some engine that will select your Spot instance, not by the type of Spot instance, but only by your requirement. Typically, CPU and memory will be the driver of that. And at some point, you'll be able to have a better utilization of your cluster. So that's it for me. If you guys have any questions, please let me know. There was a question: is it possible to get this presentation for participants? Absolutely. Be happy to share it with you. You can also ask me any question. You can send me an email if you have. I'm writing that email in the question list. I think I can put this in the chat. Yeah, in the question list. Guys, it's a pleasure to talk to you. Good luck with your Kubernetes optimization. Think of this strategy, HPA, VPA, when to use one over the other, the trade-off. If your VPA on your pod change size too much, it's a clue to say don't use VPA, but use autoscaling, pod autoscaling instead, HPA. Don't assume that your cluster should always have the same type of node. Be open-minded about it, and use, for instance, if you can, with this open-minded that you don't need to use the same family. You just need to have the requirement memory and CPU, and that's all really you need in a generic format. And please, please, please don't use, if you can, reserve instance of savings plan. I think it's evil. I hate this idea that I have to pay 1 year or 2 years in advance, or that I have to commit some money in advance. And I also hate the idea that you have to that you are giving to Mr. Bezos or Google and Azure some money that you don't really need to, and that doesn't do anything to you. So reducing and optimizing your Kubernetes applications is very, very often a positive return on investment. It's worth doing it. Believe me, we've seen it so many times with our colleagues, customers, and partners. So thank you very much. I'll give you back the 5 minutes. It was a pleasure to speak to you guys. And please feel free to ask me any questions by email. And you guys will get a copy of the presentation. Thank you.